Hi everyone, this video is for Unit 31. This is for question number 5 in the section of absorption for light, blood, and oxygen. Question number 5 is asking for oxygenated hemoglobin at wavelength of 660 nanometers. Calculate the depth at which light intensity has dropped to 70%. And so because we're dealing here with liquids, we are going to be using the intensity here we go. We're going to be using the intensity formula of I equals I naught times 10 raised to negative alpha times x, and we're trying to find x. And so the first step that we do is we make I over I naught equal to 0.7 because intensity has dropped to 70%. So now 0.7 is equal to 10 raised to negative alpha times x. And then the next step that we are going to take is we are going to insert our alpha, which we should have calculated in problem number 1. If you haven't, you'll be using Beer's law, and through that you should have gotten, or at least using the values that I had, I got that alpha was equivalent to 0.7414 inverse centimeters. So plugging that in, you then have to use log, which confused me for a while because I was trying to use the natural log, which you use when you have e in the equation, but you use log to bring the exponents down. And so with that, you end up getting this little lovely situation. And so once you have what a log of 0.7 or whatever your decreased intensity is supposed to be, you then divide that by your negative alpha value, and that ends up giving you your x value in conveniently centimeters, since that is what you were calculating your alpha values in problem number 1 if you already did that. And if not, here is the Beer's law that you would be using. So if you haven't gone and done problem number 1, you might want to go ahead and go do that, at least for the oxygenated hemoglobin at 660 nanometers. I hope that this was useful. I'm going to bring my phone out and take just a wider view of this so that everybody can get a little view of the steps in this. This was pretty easy after I did it, and deceptively difficult for the first few times that I was sort of hitting my head against the wall. So good luck, everybody!